Thanks for tuning in to the NASA SpaceX Crew-9 mission, a long-duration rotational mission to the International Space Station for NASA astronaut Nick Hague and Roscosmos cosmonaut Alexsandr Gorbunov. I'm Ronnie Foreman, a senior commercial sales manager here at SpaceX, and I'm joined by NASA's Leah Cheshire. We are just under a couple hours away from the final approach and docking of Dragon to the International Space Station. Overall, this will be Dragon's 44th visit to the space station and its 13th human spaceflight mission to the orbiting lab.
About 45 minutes after liftoff at 11:03 a.m. Pacific, Dragon executed the phase burn. This is the first of 5 major burns required to raise Dragon's orbit and position it for approach to the International Space Station. Dragon raised its orbit using the Draco thrusters over the last several hours as it continues to chase down its destination, the space station.
And then just a few hours ago, the boost burn took place at 7:58 p.m. Pacific time. The boost burn put our crew in an orbit where Dragon's apogee, or the highest point of the orbit, is about 10 kilometers lower than the station. But before we can approach the station, we need Dragon's entire orbit, not just that highest point, to be effectively shadowing the space station. So after that, we executed the close co-elliptic burn at 8:42 p.m. Pacific. The close burn placed Dragon on an orbit roughly co-elliptic with the space station, meaning that it's maintaining an orbit roughly 10 kilometers lower than the station the entire way around the Earth. Again, that's in contrast to only being 10 kilometers lower than the station during the apogee, or the highest point in the orbit, which is what was achieved by the boost burn beforehand.
Now from there, this morning, we did execute the transfer burn, 7:54 a.m. Pacific time. That's where we raised Dragon's apogee, or the highest point of its orbit, to just 2.5 kilometers lower than the station. Then we rounded everything out with the final co-elliptic burn at 8:41 a.m. Pacific to once again maintain that constant orbit lower than the station, this time just 2.5 kilometers below. That was a shorter burn lasting just over 30 seconds. And recently at 11:30 a.m. Pacific, we added in the approach out of plane burn to further refine Dragon's trajectory to the space station. At approximately 1:01 p.m. Pacific time, the Draco thrusters on Dragon will fire for the approach initiation burn when Dragon is about 2.5 kilometers below the station and just about 7 kilometers behind it. This will swing Dragon up until it's about a quarter mile, around 400 meters, directly below the station. Now, this maneuver also moves Dragon inside one of 2 checkpoints around the station that requires a set of go, no-go poles with the different control teams. The first checkpoint is called the approach ellipsoid, or you might hear us call it, or the crew call it, the AE. That's an imaginary shape measuring 4 kilometers by 2 by 2 kilometers. It's essentially a large 3-dimensional oval. Before Dragon is given permission to move inside the approach ellipsoid, the capsule is configured to be on what is known as a 24-hour safe trajectory. That means that if Dragon lost all control to its thrusters, it would be at least 24 hours before its trajectory would move it inside the approach ellipsoid.
The NASA and SpaceX teams will do a go, no-go poll to move Dragon inside the keep-out sphere, another checkpoint that consists of an imaginary sphere around the space station with a radius of 200 meters. Flight controllers use this to monitor all arriving and departing vehicles. This is another chance to confirm all of the guidance, navigation, and control systems are working correctly on Dragon before moving closer to the station. It also carries a similar requirement on orbital trajectory. If Dragon were to somehow lose control of its thrusters, it and the space station would be safe for 4 orbits, or about 6 hours, rather than the 24 hours required to enter the approach ellipsoid. Once Dragon arrives at 400 meters below the station, it will be at what's known at waypoint 0. That will be our first checkpoint during our approach. The vehicle can hold here at 400 meters if needed, but if all of the systems check out, Dragon can continue its approach to waypoint 1.
Dragon's move from waypoint 0 to waypoint 1 will swing it up and out in front of the station, arriving at a distance of approximately 220 meters. At this point, it'll be on what we call the docking axis. That essentially means it's directly in front of the docking port. Crew-9 today is headed to the forward-most port on station, so known as Node 2 forward. Dragon has docked to Node 2, also known as Harmony, for all of our crewed missions so far, because that's where both international docking adapters are located, installed for these new commercial spacecraft flights, as well as any other future spacecraft that use the international docking standard.
Once Dragon is just 20 meters away at waypoint 2, the spacecraft focuses on aligning its docking system with the International Docking Adapter. We may hear the call-out CHOP, which stands for Crew Hands-Off Point, a little less than 30 seconds before docking. At that point, any aborts will have to be done automatically by Dragon.
And of course, the grand arrival today is when our crew arrives at the space station. Dragon will fly in and make contact with the International Docking Adapter, or the IDA, and that gives us what we call soft capture. The soft capture ring will then retract until sensors indicate it's time for 12 hooks to drive in place and give us a hard capture and for firmly secure Dragon to its new home on the space station. Now, the station crew, namely Jeanette Epps, the NASA astronaut, will manually pressurize the vehicle or the vestibule, and that's the area between the Dragon hatch and the station hatch. Meanwhile, the umbilicals that provide power, audio, and data connections from the station to Dragon are put in place. And then it'll be time for leak checks and hatch opening, which is currently timelined to come a little more than 2 hours following docking. So sounds like we are on target today for a docking around 4:30 p.m. Central, so 2:30 p.m. Pacific time.
Freedom SpaceX on the big loop. Nominal approach initiation maneuver complete.
Freedom copies on the big loop, nominal AI burn, and we are complete with section 5, holding section 6 of suit donning for your go for suit leak checks.
SpaceX copies, holding in section 6. We'll give you a go for suit leak checks shortly.
Freedom copies.
Wow, check it out. That's the International Space Station, our home in low Earth orbit, and the destination of Dragon today. This point of view coming from Dragon itself. Now, we did hear earlier that the crew aboard the space station can also see Dragon at this time. So as we get a little bit closer, we might be able to see Dragon from the station as well.
And we're getting great views right now inside of Dragon, looking up at those screens as our 2 crew members begin to approach the ISS. Great views here of both vehicles on your screen. Again, if you are just joining us, that is Dragon on the left-hand side and the ISS on the right. Of course, as we get a little bit closer to docking, Dragon is actually going to swing up in front of the station to approach the Harmony module, which means that as great as this view of Dragon with the Earth in the background is, we are not going to have it as we get closer to docking because we are going to move up into that approach axis. These views we're getting of Dragon right now are incredible with the clouds on Earth in the background.
Yeah, let's take a look. It looks like they are actually flying 264 statute miles just north of New Zealand. So if we didn't have those clouds, we might have gotten a really beautiful look at New Zealand below. I'm sure they'll get plenty of chances over the next 5 months as they look out the cupola.
The views you're seeing from the International Space Station illuminating the capsule of Dragon Freedom there are covered by the setting sun and whereas we approach an orbital nighttime. As the station and Dragon Freedom pass over the western border of Quebec, the terminator line that separates daytime from nighttime is over the Atlantic Ocean. It'll be just a few minutes until the expected sunset, and we'll lose some of the views that we have currently of Dragon Freedom. Now we're getting a flashing light from the center hatch of the exposed forward bulkhead, thanks to the open nose cone. But that blinking light is called a docking light. We'll be seeing those views. As we enter into an orbital nighttime, we'll see some of the navigation lights lit up. This includes the starboard light and the port light, starboard being green, port being red. That will show the relative position and orientation and attitude of Dragon as it makes its approach to the station. Control Houston.
On the big loop. Approach 1 and soft capturing extension will begin shortly. Dragon will continue approach to waypoint 2.
That call from the ground confirms that all teams are go to proceed past waypoint 1. There will be no stopping at the waypoint 1. Dragon will execute its approach 1 maneuver burn and does have a go to enter inside the keep out sphere. This is at the 180 mark. Waypoint 2, though, is just 20 meters in front of the docking axis. We'll be proceeding in very shortly. All teams are go, everything looking good, here from the International Space Station Flight Control Room in Houston, Texas. With that, as we continue to follow along, I'll toss it back to my colleagues over in Hawthorne. Leah and Ronnie, take it away.
Awesome. Thanks, Gary. So one of the things that's really interesting as we move up to waypoint 1 is that in a lot of ways, the trajectory we're on today, even though we've done these additional burns with Dragon's Draco thrusters, was set yesterday when we lifted off from Space Launch Complex 40. And that's part of the reason that we had an instantaneous launch window yesterday. A lot of that is driven by this rendezvous point between Dragon and the International Space Station in orbit, so that we can perform all of these maneuvers moving from waypoint 1 to waypoint 2, coming up here shortly, exactly on time and through this careful, very methodical approach between all of the teams currently participating. Here at SpaceX Hawthorne, obviously our crew on board Dragon, the International Space Station, and Mission Control in Houston. We are still expecting initial contact between Dragon and the International Space Station at about 2:30 p.m. Pacific time or 5:30 p.m. Eastern time. And before reaching waypoint 1, which again is coming up here very shortly, mission operators conducted a go, no-go poll, which we just heard, to allow Dragon to begin its approach to waypoint 2. That's, of course, located inside of the keep-out sphere, about 20 meters away from the space station.
Freedom SpaceX on the big loop. Ground is go for final approach. Confirm crew readiness for approach and visors are down.
And SpaceX Freedom, visors down, we are go for docking.
SpaceX copies. As a reminder, once Dragon is inside the crew hands-off point, retreat and breakout are not permitted.
Freedom copies.
And Freedom SpaceX, we are resuming approach.
Freedom copies.
Awesome news there from Mission Control, and of course hearing our Crew-9 astronauts on board Dragon that we are go for docking. If you're watching closely, you're also seeing some great pulses from those Draco thrusters on board as Dragon approaches the ISS for that final docking maneuver.
Again, that was the final hold, and we heard the communications that we are go for docking and have resumed that approach. So we will not hold again. And they discussed CHOP, which we mentioned earlier, the crew hands-off point. That's within 2 meters from the International Space Station.
Station Houston on the big loop. Dragon is on final approach and is go for docking. Monitor per steps 5 and 6 in 1.102 Dragon approach and retreat monitoring.
Station copy, step 5 and 6.
So those sound like similar communications, but the first was to the crew on Dragon. The second is to our crew monitoring in the cupola, and you heard them reference what they should be looking at, any procedures that they're referencing during this dynamic phase. And we're continuing to see Dragon get closer to the International Space Station, now about 17 meters away from the docking port. Again, we do expect to be in an orbital nighttime during docking, but this is a pretty cool view as you can see a camera coming from Dragon and focusing on the docking port itself. So it looks like we are properly aligned with that Node 2 forward port as we continue to approach, now just 15 meters away.
Seeing good real-time readouts on your screen there. Just in the upper right-hand corner, you can see our LiDAR geometry indicating how close we are to the International Space Station. LiDAR, of course, stands for Light Radar, and it is used in maneuvers like this in space to help two spacecraft meet each other.
And that helps us to not need daylight when we are executing these maneuvers. So again, I mentioned this is happening in the dark. We can hold and wait for different lighting conditions if we needed to, but because we have this LiDAR technology, we're able to continue moving in. And like you mentioned, Ronnie, if you look in the top left, you can see we're now just about 10 meters away from the International Space Station. Oh, confirmation from the crew, 10 meters
Copy,
away.
10.
Of course, now we're also within that crew hands-off point, in large part because the autonomous systems onboard Dragon, which we're getting kind of a representation of on your screen right now, are completing this final docking maneuver. Looks like just about 7.5 meters to go.
Again, first, we will be holding for soft capture. When that soft capture ring makes contact with the space station, that will then retract and begin hard capture. But docking for us is called at the time of soft capture.
5 meters.
Copy, 5.
Standing by for the arrival of Crew-9 to the International Space Station.
We are also getting some pretty good views here of Dragon approaching station, even though we are in an orbital nighttime and it's pretty dark. That's exciting to see how close these spacecraft are to each other.
Yeah, now just about 4 meters away. Standing by for the call for CHOP, crew hands-off point.
Freedom, 2 meters, hands off.
Less than 2 meters away, standing by for docking.
1 meter.
Freedom, SpaceX on the big loop, soft capture confirmed.
Freedom, copy. Speed soft capture.
Crew-9 has arrived to the International Space Station, docking confirmed at 4:30 p.m. Central Time, 5:30 p.m. Eastern Time over Botswana.
Now, we still have a few steps to complete before Dragon is securely attached to the station, so we're going to go ahead and follow those along as well. We are standing by for the hard capture sequence start, and then we will also hear a call out for hard docking complete. We're expecting that a little bit more than 10 minutes from now.
Freedom, SpaceX, ring retraction in progress.
Freedom, copies. Retraction in progress.
Again, they're referencing the soft capture ring that will slowly retract and bring Dragon closer to the International Space Station. We'll get into that hard capture sequence with the hooks and latches, providing us a hard docking, and that happens about 10 minutes after docking itself. Again, Crew-9 arriving at the International Space Station as the station and Dragon were flying about 265 statute miles over Botswana at 4:30 p.m. Central Time, 5:30 p.m. Eastern Time.
We're a little more than 30 minutes after the docking of Dragon Freedom to the International Space Station. That docking again occurred at 4:30 p.m. Central Time, 2:30 p.m. East, 2:30 p.m. Pacific, 5:30 p.m. Eastern. Again, all the teams are working on the hatch opening operations. Commander Nick Hague and Mission Specialist Alexsandr Gorbunov inside Dragon, the view of which you can see right here, are undergoing suit doffing procedures, taking off their suits and configuring the Dragon cabin for the hatch opening sequence, including opening up of the Dragon hatch on their side. In the meantime, NASA astronauts inside the International Space Station are working on opening up the hatches on the station side. To the right of this view, where Dragon is currently attached to the station, is the International Docking Adapter that meets the two hatches, Dragon and International Space Station APAS hatches. And right on the right of your screen there, you can see the pathway on the right. That's down through the pressurized mating adapter, the black structure there on the left. With the crew of Crew-9 enabling onboard video, we now have views from inside the cabin after docking. This is inside Dragon Freedom Live right now. NASA astronaut Nick Hague at the top of the screen. Just off to the right there, mission specialist Alexsandr Gorbunov, Roscosmos cosmonaut, the two of them, are working through the procedures to open up the hatch, configure the cabin that you're seeing there inside Dragon, before opening up the hatch and entering the International Space Station. Now getting views from the two spacecraft. Again, there is a hatch, multiple hatches actually. We are seeing that the APAS hatch is open on the International Space Station side. The vestibule in between the two spacecraft have been pressurized to meet that of sea level on the ground. The position where Hague and Gorbunov currently are very close to the Dragon hatch. Now with the APAS hatch opened, some of the flashes you were seeing from inside the pressurized mating adapter were cameras, and the flashes of the cameras to inspect the hatch, make sure there's no foreign object debris, just a safety measure and precaution to make sure that nothing is in the way. That will be documented and relayed to the ground for inspection, make sure everything's good. Some of the many steps of these hatch opening procedures that we've been referencing.
SpaceX on the big loop. We see those suit fans are off. So at this time, you are go for hatch opening per the decal, followed by the remaining actions in 4.400, Section 6.
Copies, we're going to open the hatch per decal and then the remaining steps in Section 6, 4.400.
Good, readback, and we'll just follow up after hatch open on the completion of 4.012 as well, but we can go ahead and step into the hatch hops.
Okay, copy that.
With that from the SpaceX mission control teams in Hawthorne, California, relaying that the suit fan command has been successfully initiated and they are go to open up the hatch. We got a great view from inside the space station here, and we're starting to see it illuminate. And now, with that, we confirm Dragon hatch is open. 6:04 p.m. Central.
SpaceX Freedom hatch is open.
Copy, hatch open.
Freedom arriving.
The bell has been rung. Alexsandr Gorbunov, the first through of Crew-9, being welcomed by Expedition 72. Next up is Crew-9 Commander Nick Hague. Crew-9 now aboard the International Space Station and joining Expedition 72.
Station Houston, are you ready for the event?
We are ready for the event.
Station Houston, we are ready as well. Over to you to welcome the new members of the crew.
On behalf of Expedition 72, I just want to say welcome to our new compadres from Dragon Freedom. Alex, welcome to the International Space Station. And Nick, welcome back home to the International Space Station. It's great to be here with bringing the 72 back up to 11.
Thanks, Suni. Alex and I had a smooth ride up here, and so first off I just want to say thank you to the teams that got us ready to fly Freedom to the station, and it was a awesome ride. And coming through the hatch and seeing all the smiles, and as much as I've laughed and cried in the last 10 minutes, I know it's going to be an amazing expedition, so I'm really looking forward to getting to work up here.
So I'm very happy to be here in this huge, amazing laboratory, International Space Station. And I'm looking forward to working with this crew, Expedition 72, and with people who are supporting us on the ground, МСС Houston, МСС Moscow. Также хотел поблагодарить НАСА вместе со SpaceX и Roscosmos, которые продолжают сотрудничать по программе МКС, продвигают науку, эксперименты космические вперед. И хотел поблагодарить всех родных и близких за то, что меня поддерживали в этом путешествии, которое только начинается. Завтра первый рабочий день. Начнем работать. Спасибо.
Thank you for the words. At this time, Glavany has an additional message for Nick and Alex.
ЦУП Москвы на связи. Я надеюсь, вы меня сейчас хорошо слышите. Я приветствую всех. Здравствуйте, добрый вечер. Ника и Александра мы приветствуем отдельно, особо поздравляем с благополучным прибытием на борт и началом космической вахты. Удачи вам. Долгим разговором сейчас утомлять не буду, потому что, понимаю, насыщенный день, вы устали. Благодарю за внимание. Удачи, удачи, еще раз удачи от всех нас. Мы на связи и готовы вам помочь всегда.
Спасибо за теплые слова. Будем работать с завтрашнего дня, да. Начнем космическую вахту, посмотрим, сколько продлится.
And with that, thank you to all participants. Station, we are now resuming operational audio communications.